Today we're solving 3 minus 3 times 2 minus 2. We're going to start by analyzing the common error that leads to an incorrect result, and then apply the strict algebraic hierarchy of operations to find the single exact value. Let's first look at the incorrect way this problem is commonly solved. Many people mistakenly calculate operations, strictly from left to right as they read them, totally ignoring operator priority. Subtracting the front 3 minus 3 gives 0, and then multiplying 0 by 2 gives 0. And finally, subtracting 2 leaves an incorrect answer of negative 2. So now let's solve it the correct way by isolating the operator with the highest priority rank. According to the foundational rules of PEMDAS, multiplication must be executed completely before addressing any subtraction operations on the board. The positions of the numbers from left to right do not alter this rule. The center product is our mandatory starting point. First, we evaluate the central product by multiplying the integer 3 by 2, which equals 6. Then we substitute the product 6 back into the center slot, while keeping the surrounding operators intact. This simplifies our running expression to 3 minus 6 minus 2. The remaining string contains two operators of the exact same type, subtraction and subtraction. Because they share an identical priority rank, we must calculate the term strictly from left to right. This makes our next mandatory operation the front block, 3 minus 6. Now we can perform the subtraction step on the left by taking 3 and subtracting 6. Moving 6 units to the left of 3 on the number line drops the value below 0, resulting in negative 3. Bring down the final term to update our running string, negative 3 minus 2. Executing the final subtraction step to complete the problem. Subtracting 2 from negative 3 gives us negative 5.